We're now looking at the tomatoes of the bun, and one of the whole plant hormones is called ethylene. And as you all have hormones in you right now, the hormones in your body right now are telling you to grow. The plant hormone ethylene tells the tomato to ripen. Part of the ripening process is turning the starch in the tomato to sugar so that it turns nice and sweet, and also for the tomato to turn red. Now ethylene looks like this, and it has what we call a carbon-carbon double bond. It also has single bonds between the hydrogen and the carbon atom. Now a bond, we're going to be looking at bonds. A bond is how atoms join together, and we're going to be looking at two different types of bonds: ionic bonds and covalent bonds. So again, a bond joins two atoms together. Okay, well, we know the noble gases, which is this last group of the periodic table, they don't like to form bonds with any atoms. They seem quite happy to be unsociable and be on their own. So why is this? Well, if we look at the noble gases, helium has 2 electrons in the first shell. That shell is full. Neon has 8 electrons in the second shell. That shell is full. Argon has 8 electrons in the third shell. That shell is full. So it appears that the noble gases don't form bonds with other atoms because they have a full outer shell. Now, in ionic bonds, the atoms want to become like the noble gases. They want a full outer shell of electrons. And they can do this by, they can either lose electrons. If they lose electrons, they end up with a positive charge. Or they can gain electrons, and they end up with a negative charge. So if one atom gives an electron to another atom, you're going to end up with one of the atoms is positive, one of the atoms is negative. There is attraction between positives and negatives, and this is the ionic bond. This is what holds what we call now, these are called ions together. So this is an ionic bond, that's the bond attraction. Now our experiment, we made an ionic bond. So we took magnesium, the element magnesium. Magnesium is a metal, and it looks like this. We took magnesium and we burnt it, and to burn things you need oxygen. So every time you burn something, oxygen is involved, oxygen from the air. So I'm just going to put the magnesium into the Bunsen burner. This gives enough energy to start the reaction off. Very, very bright flame. Magnesium is burning in oxygen, and we end up with magnesium oxide, sort of a white color. Okay, so what's happening in this reaction? Well, magnesium has an atomic number of 12, which means it has 12 electrons, 2 in the first shell, 8 in the next shell, and 2 in the outer shell. To achieve a full outer shell of electrons, it needs to lose these 2 electrons. Oxygen has an atomic number of 8, 2 in the first shell, 6 electrons in the outer shell. To get a full outer shell of electrons, it needs to gain 2 electrons. So what happens here is the magnesium, when you burn it in oxygen, the electrons are transferred over to the oxygen. The magnesium oxide ends up, we have a 2 positive charge on the magnesium, a 2 negative charge on the oxygen, and the attraction between the positive and negative is called the ionic bond. Now, how do we work out the charges? As I said, magnesium in the periodic table has an atomic number of 12. Show you that. So we have here magnesium, it's at number 12. Oxygen has atomic number of 8. This means it has 12 protons and 12 electrons, so the element is neutral. If it loses 2 electrons, we now end up with 12 positives and 10 negatives, and overall that gives us a 2 positive charge. Oxygen has atomic number 8, 8 protons, 8 electrons. Again, the element is neutral. If it gains 2 electrons, it now has 8 positives, 10 negatives. Electrons are negative. overall charge is 2 minus. Okay, one of the questions was how would magnesium react with fluorine? What would be formed? Okay, here I'm just showing the outer 2 electrons. So again, magnesium wants to lose 2, but fluorine has 7 electrons in the outer shell, so it only wants to gain 1. So what happens here is that one of these electrons goes to fluorine. Fluorine is now happy, but magnesium isn't. It still has 1 electron left over, so we need to take another fluorine. So this electron here will go to the second fluorine. So we end up with a compound. Again, magnesium has lost 2 electrons. It has 2 positive charge. Each fluorine has gained 1 electron. Each fluorine has a 1 negative charge, but this 2 tells us that there are 2 fluorines. So magnesium needs to react with 2 fluorines to achieve a full addition. A couple more questions in the OneNote I haven't addressed yet. Whatever chemicals we start out with, and I'm just showing A and B can represent any sort of chemicals, those are called the reactants. When they combine in a chemical reaction, we get new chemicals, and here I'm just representing them as C and D. Those are called the products. Also, it said what is an ion? An ion is a charged particle. For example, magnesium has a charge of 2 positive, that's an ion. O2 minus is also an ion because it has a charge of 2 negative. So anything with a charge on it is an ion.